Hi students, in this session we will discuss about refraction of light by a glass prism, dispersion of white light by a prism, atmospheric refraction and finally scattering of light. Now let us start with refraction by a glass prism. Have you seen a glass prism? Triangular glass prism? Let us have a look. Okay. Now a triangular glass prism has two triangular bases and it will have three lateral surfaces. The angle between two lateral surfaces is called angle of the prism. Now let us do an activity to find the refraction through this glass prism. Now take a glass prism ABC. We have taken a glass prism ABC here. You see, draw a line inclined at the surface or at the side AB of the glass prism. Now you have to fix two pins at the points P and Q. You can take two pins or you can make some dark dots at the points P and Q. Now you have to look through the image of these two pins or these two dark dots through the other side of the glass prism, that is AC. So you have to look through the side AC. You are looking at the image of P and Q, so that you have to mark 2 points on side AC. That point should be R and S such that P, Q, R and S all should be in same straight line. You see, you got the 2 points here now, R and S. Now if you look through the other side AC, what you can see? This P, Q, R, S, all these points or all these 4 pins will be in same straight line. Now you remove the glass prism, join PQ to the side of the glass prism, that is till the edge E. Now what is the emergent ray? That is RS. Just join RS to F. Now join EF inside the prism. You see, now you can draw a normal at E. Now you can find what is angle of incidence and angle of refraction. See, I is the angle of incidence and R is the angle of refraction. Similarly, draw a normal N dash at F and you can mark the angle of emergence there. You see, the incident ray, what happens to incident ray at the edge AB of this prism? You see, the light is traveling from air to glass, that is from rarer medium to denser medium. So we have seen what happens in the previous chapter. The light bends towards the normal. So the light ray, that is PQ, gets refracted and travels along EF. Now what happens to this light ray at F? At F, the light ray is traveling from glass to air, that is from denser medium to rarer medium. Then what will happen to the speed of light? Speed of light increases and the light ray or the emergent ray move away from the normal. Why? Because the speed has increased. Now the emergent ray is, Fs is the emergent ray. Now if you extend the emergent ray to the incident ray, that is just you have to extend the incident ray PQ here. Now the emergent ray, if you extend, that emergent ray will meet at the incident ray at a point. And the angle formed between the emergent ray and the incident ray, that is known as angle of deviation. Here, angle of emergence will be equal to angle of deviation. You see, here what about the direction of incident ray and the emergent ray? Are they parallel? They are not parallel. Why? Because the edges, the lateral surface of prism are inclined and it forms an angle there. But what about the incident ray and the emergent ray in case of a refraction through a rectangular glass slab? We discussed in the previous chapter. You see, that incident ray and the emergent ray, that will be parallel. Why? Because the refraction takes place at the two edges of rectangular glass slab and those edges were parallel and the bending, the extent of bending of light takes place on either side of this glass slab, rectangular glass slab, it was equal and opposite. But here it is not like that. So here the incident ray and the emergent ray, they are not parallel. Now let us discuss about dispersion of light by a glass prism. You see, when a white light is passing through a glass prism, the dispersion takes place. That means the white light splits into its component colors and you get a band of colors, and we call this band of colors as spectrum. Let us have a look at the figure. You see, when white light is incident on one side of a triangular glass prism, what is happening? The dispersion takes place. And when the emerged light, when it is caught on a screen, you can find 7 colors. Those colors are Vibgyor: violet, indigo, blue, green, yellow, orange, red. You see, why all these colors have deviated at different angles? Why? Because different colors have different speed in a medium. So all these colors deviate at different angles, and you can see violet deviates the most and red deviates the least. So see, all these colors are the component of white light, but still all these colors are bending at different angle because of difference of speed in a medium. So different colors have different speed in a medium. Now this phenomenon was first observed by Sir Isaac Newton. Now he got a spectrum of colors here. Now he tried to split these 7 colors into different colors, but he couldn't split these 7 colors into different colors again. But when he placed another prism identical to the first prism in an inverted position, and when these 7 colors pass through one face of this inverted prism, on the other face he got the white light back. Thus he concluded that white light or sunlight is made up of 7 colors. Have you seen rainbows in the sky? You might have seen that. That is the natural spectrum of sunlight. You see, rainbow is formed just after a rain shower. You see, after a rain shower, there will be water molecules suspending in the atmosphere. These water molecules act as small prism. You know that rainbow is always formed opposite to the direction of sun. So when the sunlight passes through these water droplets, which are acting as glass prisms, what happens? Let us look at the diagram. When the sunlight is passing through the water drop, at the first phase, it gets refracted and dispersed. Dispersion means it splits into 7 colors or into its component colors. Refraction means change in or bend in the path of light. So at the first phase, what happens? Both refraction and dispersion takes place. Now this dispersed light passes through the water drop, and at the other end of this water drop, it is not refracting to the other side, but what is happening? It gets reflected internally. This process is known as total internal reflection, TIR, and you learn about this phenomenon in your class 12 physics. Now let us discuss about how is a rainbow formed. See, the incident ray, when it touches the surface of water drops, it gets refracted and dispersed. That is the first phenomenon. Gets refracted and dispersed. And this dispersed light, when travels along the or through the water drops, what happens to the other side? It gets reflected internally. It gets reflected internally. And this reflected light, when reaches the first side again, what happens? It gets refracted. So when this light reaches our eyes, we see a rainbow. So what are the sequence takes place, or the phenomenon takes place in the formation of a rainbow? The first one, refraction and dispersion. Second one, total internal reflection. Finally, gets refracted again. So all this process, you should, in your examination, this question is a sure question. You should mention all these points one by one. First, the incident light gets refracted and dispersed. Dispersed light gets reflected internally, and finally it gets again refracted and comes out of the raindrop, and we see a rainbow. Now let us discuss about atmospheric refraction. We have discussed refraction in the previous chapter. What is refraction? The bending of light when it travels from one medium to other. That is known as refraction. Now what will be atmospheric refraction? You see, atmosphere, it has different physical conditions. That means in different layers of atmosphere, it has different density, different temperature, the size of dust particles and water droplets, the amount of water droplets, all are different. So physical condition of earth is not stationary. So when light travels through the atmosphere, what happens? Light gets refracted or the direction of light changes. This is known as atmospheric refraction. Now let us discuss about some applications of atmospheric refraction. The first one is twinkling of stars. You might have seen the stars twinkling in the sky at night. Let us see how stars twinkle. You see, star is a very distant object. That means the star is very far from us. The starlight that comes from the star has to travel through different media. You see, from the star to the atmosphere, the starlight is passing through the vacuum. But once it enters the atmosphere, what happens to the starlight? The direction of starlight changes. Why? Because of refraction. You see, the starlight is entering from a rarer medium to a denser medium. What is rarer medium here? The space, that is a rarer medium. What is a vacuum? That is a rarer medium. What is the denser medium? The atmosphere is the denser medium. You know that when light travels from rarer to denser, it comes close to the normal. So the direction of light changes when it enters the atmosphere. So position of the star seems to be little bit at the higher position than its actual position. That is known as the apparent position of star. I told you the star is very far, so it can be considered as a point source of light. You see, from a particular point the light comes out. That is point source. Because the reason why the star is a point source of light, because it is very far from us. That's the reason. So when this starlight passes through the atmosphere, we have already seen that the physical conditions of the atmosphere that varies always. So when this starlight passes through the atmosphere, what happens? Its path changes. So it makes or it creates a flickering effect in our eyes. That is known as twinkling of star. So once again, how do stars twinkle? It is because of atmospheric refraction. One more point is there. Star is a very distant object, so it can be considered as a point source of light. So when the starlight reaches the atmosphere, as the physical condition of atmosphere is not stationary, as it is varying, what happens to the path of light? Path of light always gets changed. So when this light reaches our eyes, it seems to flicker. You know, sometimes it flicker brightly, sometimes it is dimmer, and this effect is known as twinkling of stars. Then arises another question: why don't planets twinkle? Why? Because planet can be considered as an extended source of light. What do you mean by extended source of light? A simple example I will tell you. A laser light you might have seen, that can be considered as a point source of light. But a tube light that we have in our home, that can be considered as a extended source of light. You see, extended source of light can be divided into a large number of point source of light. So from all these point source of light, what is coming out? Light is coming out. So when the reflected light from the planets reaches our eyes, actually it travels to the atmosphere, and what is happening? The bending takes place. But when the light travels from large number of point source of light, what happens? The effect, twinkling effects, it gets nullified, or the bending of light, that effect gets nullified. So we do not see the planets twinkling. Now let us discuss about advanced sunrise and delayed sunset. You see, this is also an application of atmospheric refraction. We say that actually the sun has risen when the sun is above the horizon. You can see here, we have drawn the horizon. When the sun crosses the horizon, the actual sunrise takes place. But when the sun is below the horizon, we can see the sun. How? The sunlight passes through the atmosphere. What takes place? Refraction takes place. Because from sun to atmosphere, the light travels through vacuum. But when it reaches the atmosphere, what happens? It is entering into a denser medium. So what happens? The light bends towards the normal, or we can say there refraction takes place. So the position of the sun seems to be little bit above the actual position of the sun, and that is known as apparent position of the sun. Because of this atmospheric refraction, we are able to see the sun 2 minutes before the actual sunrise. The same reason we can see the sun after sunset. This is known as advanced sunrise and delayed sunset. Now we will discuss about scattering of light. In this topic, we will discuss Tyndall effect. I think you might have learned this in your class 9 chemistry when you discuss about different types of solution, properties of solutions. Then we will discuss about why the color of clear sky is blue. Then we will discuss about the color of sun during sunrise and sunset. Now let us start with Tyndall effect. What do you mean by Tyndall effect? Colloidal solutions show Tyndall effect that we have learned in class 9. Let us see what is Tyndall effect. You see, the atmosphere is made up of different types of gas particles, small dust particles, or we can say tiny water droplets. All these are present in the atmosphere. So when the sunlight passes through the atmosphere, these minute tiny particles, it scatter the light, or what do you mean by scattering? Redirects the incident light, that is known as scattering. So all these tiny particles scatter the light, and thus the path of light becomes visible. This is known as Tyndall effect. When sunlight passes through a canopy of dense or thick forest, this Tyndall effect can be observed. Now let us see why the color of sky is blue. Atmosphere is made up of tiny particles. It has dust, air molecules, water molecules, etc. So the fine particles in the atmosphere that have size smaller than that of visible light, or the wavelength of visible light. So what happens? These fine particles scatter the light of shorter wavelength. Shorter wavelength means the light includes violet, indigo, blue. All these colors have shorter wavelength. So these tiny particles scatter the colors of shorter wavelength. So we see the sky, the color of sky as blue. Now you see, for an astronaut, what will be the color of sky? You see, for him, the sky will be dark in color. Why? Because there is no atmosphere. So scattering of light do not take place. Now let us see what is the color of sun during sunrise and sunset. It is reddish in color. Why? Because during sunrise and sunset, the sun will be at the horizon. So the sunlight has to travel long distances through the atmosphere. So actually what is happening? The light of shorter wavelength gets scattered away by the particles, and only the longer wavelength colors, that is the red region colors, reaches our eyes. That's why the color of sun during sunrise and sunset is reddish.